This is the axis of rotation. Rotating. Everybody can see that it's rotating, not translating. When you don't see that the axis of rotation is moving, it's rotating. So, what type of kinetic energy then will have the object? Kinetic, which will be 1/2 I omega square. I am looking for omega, but I need to know what is L or what is I. If it's rotating about the end, what will be the moment of inertia of the rod about the end?
ml squared
Over 3. Over 3. With respect to the center of mass, will be over 12 times omega squared. M. L, the square. 2. What will be omega? Omega squared will be G over L times 3, the square root. This is omega. Any question finding omega using energy? EI is equally final, the same thing that we did for a pendulum. This can be a typical question, multiple choice. What will be the change that I can put in the test? I don't have to give that this is rotating with respect to the end. I can put the axis of rotation here. Let's say, for instance, 0.25, 1/4 L. What is the only thing changing in the problem? That's an arbitrary axis. So in order to find the moment of inertia, what you have to apply? The only thing that will change here will be the axis of rotation is here, right? This is moving like this. What will be H? 1/4 of L. That's one change. What will be I? You need to find it. What formula we apply to find it? What is the formula to find I here?
I, the center of the mass.
I of the center of mass plus md squared. And what is the new d?
That's
1/4 of L, 0.25. You don't know if that will be a meter stick ruler or 2 meter ruler. You don't know. But will be md squared. So the only thing that will change is how far is this and how much is the potential energy. Now the potential energy will be only L over 4. Here. So it's rotating with respect to here. And the moment of inertia is just md squared, and d is the distance from the axis of rotation to the center of mass. Parallel axis here. Good. With this we finish. Yes, energy. I just forgot to say that. Let's go to the multiple choice. To the study guide. If you go, so in question, you can see that question 10 is, I just asked for the acceleration, initial angular acceleration of the stick. Can you see? Initial angular acceleration of the stick, which is when it's horizontal. When originally it released from the horizontal position. I can release from a certain angle, which I did in class. So I can release in the test from here or from a certain angle, which I did in class. I mean, I am talking about multiple choice. Then, that was to find the acceleration. But if you go to question 11, Okay. In question 11, you have slightly different. Let me just see if there is another one. So in the, okay, question 12. I will go back to question 11. But question 12. A uniform rod, the mass 1.5 kilogram and 2 meters long. The rod is pivoted about a horizontal frictional spin through the end. The rod is released from rest in a horizontal position. And the question is, what is the angular speed of the rod when the rod makes an angle of 30 degrees with the horizontal? 30 degrees with the horizontal. That is more complicated. So, it's not here, will be here. 30 degrees with the horizontal. This is this. So this is moving from here to here. So the height, this is here. The center of mass is here. It's moving with respect to the end. To one end. So I need to get this height, but this is going this way, like this. So from here to here is like this. I have this. So if I have this triangle, and here I have to use some kind of socapoa. This, you have this, you have this, and you have this. And this, they said that is a 30 degree. So somehow, you need to figure out what will be this height. This height, which is the same than this height. Okay, let me see if it's sine or cosine. So we have this, we have the length, which is L over 2. This is 30 degree. So this will be 60 degree. And this is the adjacent side of 60 degree. Can you see that? So L over 2, the height, I'm talking about the height, will be L over 2 cosine of, instead of 30, 60 degree. Can you see that? It's very complicated, but you have to look at the picture and figure it out. So this is because it's 30 degrees, but if it's the whole thing, it will be L over 2. But in this case, it was a little bit more complicated. So the height is that we want to find the speed, but the moment of inertia is about the end. So what will be the formula? In this case, EI is equal to final. mg, in this case, will be L over 2 cosine theta, cosine 60 degree. In this case, will be cosine 90, which is the same than sine theta. Cosine of 90 minus theta is the same than mg L over 2 sine theta, which in this case is 30 degree equal 1/2 I omega squared. And you find omega. I ml squared over 3 because it's rotating with respect to the end. So this is more complicated because it was at an angle. This is the more complicated situation you can have. But if I ask at the bottom, it's less complicated, which is what I did here. Okay, any questions? The previous one, 11, is very simple because you have one mass like this